All right. So good morning to everybody. I'm going to ask you to begin by copying what you see there, and make sure to emphasize this. So if you would begin by copying that, please. Again, good morning. Begin by copying what you see. So we have three possibilities. We have basically the same formula. We have three different ways of doing this. Okay. We have something called an acute triangle with one formula, right triangle, different formula, and obtuse triangle, third formula. But the only thing that differs between it is the symbol. Greater than, equal to, less than. All right, ladies, begin please. Now, with this information, tell me I'm going to say use the Pythagorean theorem to decide what kind of triangle you have. And so I'll set it up like this. I'll say example, and I'm just going to call them ABC for all three. So A, B, C. And I'll say that this is 5, 12, and 13. Then the second one, I'm going to say ABC as well, which is the same formula. And this time I'll say that it's 5, 6, 7. 5, 6, and 7. And then the third example is still ABC. And there'll be 3, 3, and 5. And so the issue is that I basically have the same formula. In order to do any kind of check, I would always start with the original one here in the middle, and then basically use that to decide which one's which. with this information, we're still continuing with the converse of the Pythagorean theorem. So I'll move it up this way so it's a little bit easier to see. And for those who are not sure how to start, this is what I would suggest. No matter which one you're dealing with, always begin with the original rule. So automatically say a squared plus b squared equals c squared, automatically. Don't start with greater than, don't start with less than, automatically just a squared plus b squared equals c squared, or all three. So all three start the same way. I don't know what kind of triangles they are when I first start, so instead of trying to make that decision from the beginning, we just start with assuming that they're equal. And if we assume that they're equal, then we'll decide at the end of it, yes, it's true, no, it's false. Okay? Julian? So plug it in. You already know what A is, B, and C for each section. If you're not so sure about your squares, I have them up on that wall on the side, and you can also use it off for your phone. So, and you have your times tables pretty much everywhere. Some of you still have that little card, for example. So there's several choices for that. All right. Minimize it just slightly so that I can still see my information. And so here's the deal now. For the first one, I'm going to write it down as 5 to the second power plus 12 to the second power equals 13 to the second power. So I'm just literally making the change of the number. Everything is to the second power. Now, if I do that, anybody please call it out. What is 5 squared? So 5 squared is 25. Thank you for that. 12 squared. What is 12 times 12? 144. And then last but not least, 13 squared. 13 times 13. Again, it's posted up there, or you can look it up, one or the other. Whichever one's easier for you. So what is 13 squared?
169.
169. Now, as soon as it looks like this, I take 25, I take 144, I add it, so I'm going to add this side. I don't have to do anything on the other side. I add this side, and it seems to be that this is 169 as well. So 169. And so the other side is also 169. And because of this, then our conclusion with this piece is very simple. Our conclusion is that this must be a right triangle. And the only reason I know that's true is because of this information. Right? So at this point, take out some regular paper if you have to, and copy the information down. On the second one, I end up with 5 squared, 6 squared is equal to 7 squared. All right, Justin, start me off. What is 5 squared? Basically 5 times 5. Thank you, sir. So I have 25. Julian, 6 squared. Wrote this wrong. One more time. Thank you. And Andrea, could you give me 7 squared? And again, it's up there and or on your phone or whatever you have. What is 7 squared? Okay, so I'm hoping I heard correctly. And this is 49. I'm still going to add together. That doesn't change. So when I add together, I have 6 and 5 make 11. So I carry the 1. 3 and 2 make 5. 1 more makes 6. So this becomes 61. But it's obviously not the same as 49. So as soon as I decide this is not the same as 49, which symbol is it? Is it greater than or is it less than? So we start from left to right. So 61 is what to 49? Greater than. So in here, I now say 61 is greater than 49. So our conclusion is that because this is greater than, then our conclusion is this must be acute. So we say this is an acute triangle. And it's only because of the symbol. That's the difference between one or the other. All right, last one is going to say 3 squared. Plus 3 squared is equal to 5 squared. So the numbers are not particularly difficult, very straightforward. 3 squared would be very simple. We know that's 9 plus 9. And 5 keeps coming up, so that's just 25. So the only thing I have to check for right now is what makes 9 plus 9. So 9 plus 9, I know, makes 18. But again, we're right back at the same situation. This is not equal to 25. Now, the first time that happened, I ended up saying that 61 is greater than 49. But in this situation, I have to say that 18 is what to 25? So 18 is less than 25. And as soon as I say greater than, equal to, less than, then that means that this must be an obtuse triangle. So this is an obtuse triangle. And again, exact same formula, yet it gives me very simple information. Okay? And I don't have to change what I'm doing. I'm still working with the Pythagorean theorem, but now I have more variety because I can deal with different kinds of triangles. Any quick questions on this part?